Hello everyone. Let's start with a fun thought. Have you ever tried to pour air into a bottle? You can't see it, but it always manages to sneak in and take up every bit of space available. Unlike solids, which stubbornly hold their shape, and liquids, which politely sit at the bottom of a container, gases are the free spirited wanderers of matter. They don't care about shape or volume, they just spread and occupy all available space. Why? Because their molecules are far apart with almost no attraction between them. They move continuously, bouncing around like restless kids in a playground, only restricted when they hit the walls of the container. That's why gases always take both the shape and volume of their container. Now, here's something really cool, literally. Have you seen those large gas cylinders that store oxygen or LPG? Imagine stuffing something as free moving as gas into a heavy metal container. That's possible because gases are highly compressible. Their molecules are like distant neighbors living far apart, with huge empty spaces in between. When pressure is applied, these molecules can be squeezed closer together without resistance. This property allows us to compress large amounts of gas into small cylinders, making transportation and storage practical. Compressibility is also the reason gases can be liquefied under high pressure and low temperature, like turning oxygen into liquid oxygen for hospitals. Here's another striking property. Unlike water, which pushes mainly downward, gases are democratic. They exert pressure equally in all directions. Picture molecules zooming around in a container, colliding against the walls. Each tiny impact contributes to the pressure we measure. Pressure is nothing but force per unit area, created by the molecules striking the walls continuously. That's why a balloon inflates uniformly in all directions and doesn't bulge only at the bottom. It's also why divers feel pressure from all sides underwater, because the gases dissolved there follow the same rule. Equal, uniform, isotropic pressure is the secret superpower of gases. Now let's talk about density. Why does a helium balloon float while a stone sinks? Density is simply mass divided by volume, and gases have astonishingly low densities. The molecules are so widely spaced that the number of molecules per unit volume is very small. Compare this to solids or liquids, where molecules are tightly packed. That's why gases occupy far greater volume for the same mass. For instance, if you vaporize a small cube of ice into steam, the volume expands many times over and density drops drastically. This property makes gases lighter, which explains why hot air balloons and helium balloons rise against gravity. Here's my favorite property, the magic trick of gases mixing on their own. Imagine spraying perfume in one corner of a room. Within minutes, everyone can smell it even at the far end. That's diffusion in action. Gas molecules are in constant random motion, and since the spaces between them are large, they slip into each other quickly and form homogeneous mixtures. Gases don't need stirring, they mix uniformly in any proportion. That's why our atmosphere is a perfect cocktail of nitrogen, oxygen, carbon dioxide, and trace gases. This also explains why a gas leak in a kitchen quickly spreads across the entire house. Safety first, always ventilate. Let's take this one step further with some numbers. The Scottish chemist Thomas Graham discovered that lighter gases diffuse faster than heavier ones. His law says the rate of diffusion is inversely proportional to the square root of the molar mass. Mathematically, rate of gas A over rate of gas B equals the square root of molar mass of B divided by molar mass of A. For example, helium with molar mass 4 diffuses much faster than oxygen with molar mass 32. If we apply Graham's law, the ratio of their diffusion rates is the square root of 32 over 4, which equals the square root of 8, approximately 2.8. So helium diffuses almost 3 times faster than oxygen. That's why lighter gases like hydrogen and helium escape Earth's atmosphere easily, while heavier gases remain bound. So, to wrap it up, gases are the free spirited state of matter. They have no fixed shape or volume, expand freely, and can be compressed into small volumes. They exert equal pressure in all directions, are low in density, and diffuse rapidly to mix with other gases. These unique properties make gases indispensable in real life, from storing fuel and oxygen to weather systems, balloons, refrigeration, and industrial processes. More importantly, these behaviors set the stage for gas laws like Boyle's and Charles's law, which explain how gases respond to pressure, volume, and temperature changes. Remember, every breath you take is proof that gases are not just invisible, they are dynamic, powerful, and life sustaining. Until next time, keep looking for the chemistry that's literally in the air around you.